Is rotational kinetic energy conserved? Kinetic energy is even conserved in the rotational motion of an object. We know that kinetic energy is conserved in translational or linear motion, and we find out using the formula Ke equals 1/2mv2. Similarly, even in rotational motion, Ke is conserved, and it is known as rotational kinetic energy. Here the energy changes into heat when friction occurs. Now it's time to know if kinetic energy is conserved in the oblique collision. Is kinetic energy conserved in the oblique collision? We'll conserve kinetic energy of the system of objects in an oblique collision if it is elastic. In an oblique collision, the object at the static position will possess some velocity that will be normal to the initial object. As the collision will be elastic, the total amount of momentum and the kinetic energy, Ke, of the system of objects will be conserved. If it is an inelastic collision, Ke will be transformed into sound or heat and is not conserved. Is kinetic energy conserved in an isolated system? In an isolated system, the kinetic energy of the system of objects is conserved. An isolated system of objects is a system that does not get affected by the external influences that result in the alteration of the momentum of the system. The kinetic energy in an isolated system is conserved since the other factors such as resistance, friction does not affect it. Ke inside it converts into different forms and stays inside an isolated system. Now let us concentrate on the aspects that tell how kinetic energy is conserved in angular momentum. Is kinetic energy conserved in angular momentum? In general, when angular momentum acts on a particle, it is conserved, but that body's kinetic energy will not be conserved. Angular momentum and Ke are inversely proportional to each other. If there is a collision of objects and it is inelastic, then the Ke will not be conserved, but the angular momentum of that object will be conserved in the system because there will be no torque since the outer force is not balanced. Kinetic energy usually does not conserve angular momentum. Now, let us focus on is Ke conserved in rotational motion. Is kinetic energy conserved in rotational motion? We know that in rotational motion, the particle's kinetic energy in motion is conserved. As in linear motion, Ke is conserved. Similarly, kinetic energy is conserved in the rotational motion of an object. Here the kinetic energy is known as rotational kinetic energy since it occurs due to rotation of the body, and it is a component of total Ke. The conservation of Ke for different conditions is possible by considering the factors affecting the system of objects. When is kinetic energy conserved? If the type of collision is elastic, then the kinetic energy is conserved. In an elastic collision, when the two objects have some masses collide, they stick together or deform while colliding, i.e., the Ke before and after the process of collision will be equal and the Ke will be conserved. It can be further said from the conservation of momentum. If we take an example of pool balls, the target is hit, the balls collide with each other, move further from each other. In an inelastic collision, the masses of any two or three objects stick together. Now let us know the conditions of conservation of kinetic energy. Under what conditions are kinetic energy conserved in a collision? The necessary condition where the particle's kinetic energy can be conserved is only in the perfect collisions that are elastic in nature. In general, the kinetic energy will be conserved in rare processes. Despite this, W will conserve the total energy in all the processes. Only in the perfectly elastic collisions, the Ke be conserved. If an object is static initially and then starts to move, the Ke of the object will be converted into momentum, and here some amount of Ke will be lost and is not conserved. So, there are minimum conditions under which Ke is conserved. The formula used to find the kinetic energy of a body. The formula used in general to know the value of Ke of a body is given below. Kinetic energy equals Ke equals mv2. In the formula above, the terms m equals object's mass. V equals object's velocity in a motion. Now it's time to know the nature of the conservation of kinetic energy. Is kinetic energy a vector or a scalar physical quantity? From the formula used to know the value of Ke, we can easily find out its nature. In the formula of Ke, the mass is the scalar physical quantity and velocity is the physical vector quantity. Another important fact to notice here is that the velocity is squared, and we know that the square of any vector quantity is called a scalar. As both the terms of Ke are now scalar, we can say that Ke is a scalar quantity. Now let us know at what condition kinetic energy is maximum. At what condition the kinetic energy will be maximum? Even the answer to this question is based on the formula used to calculate kinetic energy. Both kinetic energy and potential energy sometimes go hands-on, so for Ke to be maximum, the potential energy must be maximum, and this potential energy will be maximum when the object's velocity is maximum. The mass of the object in consideration must be at equilibrium. If all the above conditions satisfy, then the Ke will be maximum. Can kinetic energy be conserved in an explosion? Kinetic energy is not a conservable quantity in explosions. It is a general fact that explosions occur when one type of energy transforms into another form. The chemical energy present in a particular process is lost in heat or Ke that may lead to the explosion. So, we can say that Ke is not conserved in an explosion. However, we learned that kinetic energy is conserved in explosion materials. Can kinetic energy be conserved in an inelastic collision? It cannot conserve even a tiny amount of kinetic energy in an inelastic collision. It is known a fact that in a collision that is inelastic, not even a tiny quantity of Ke will be conserved. In the inelastic collision, some Ke is converted into heat or any other form when the objects stick, and these energies are dissipated. However, we learned that kinetic energy is conserved in explosion materials. What happens to the kinetic energy when the object's speed is decreased? The transformation of energies takes place when the object's speed decreases. When the body's speed decreases, the Ke present in the object will be converted to another form such as potential, heat, or sound energy, i.e., we can say that when the speed decreases, Ke will be transformed to other forms. Now let us see how this kinetic energy transformation occurs. How does kinetic energy transformation occur? To understand the transformation of kinetic energy, we can take a simple example of the yo-yo toy. You have to keep it at rest, and then pull the string first to play a yo-yo. There will be potential energy. After pulling the string, the toy falls and gains Ke. Here the Pe is converted into Ke. In this way, the stored potential energy will be transformed into the Ke when motion occurs. Now let us know some basic examples related to kinetic energy. What are the examples of kinetic energy? We know that Ke depends on the mass and velocity of a body, so based on this, the widespread kinetic energy examples are as follows. A lorry traveling on the street has more Ke than a car that travels at the same speed on the same street because the mass of the lorry is more. A flowing water body consists of kinetic energy as it flows at a certain speed and consists of mass. All celestial bodies such as asteroids and meteoroids are large and travel at a certain speed. When they tend to fall towards the Earth, they consist of Ke. These are some examples of kinetic energy. Frequently asked questions on conservation of kinetic energy, FAQs. What do you mean by kinetic energy? The simple definition of kinetic energy given in physical sciences are as follows. When an object is in motion, some amount of energy is possessed by the object due to its motion, which is used to measure the work done by the body. If a body needs to be accelerated, we need to apply some force. To apply the required force, some work is to be performed after this energy is passed to another and provides motion to the object. The passed or transferred energy is called kinetic energy. Why is kinetic energy always conserved? Kinetic energy is not always conserved in all the processes. Only the body's total energy is conserved. In any collision, the Ke is not conserved except for the elastic. In a motion, the Ke before and after the collision of objects will be different due to loss of energy and external conditions. What are the essential facts about kinetic energy? The essential facts about kinetic energy are given below. The kinetic energy is a vital scalar physical quantity. It is measured in ergs. There are two specific types of kinetic energy: rotational and linear or translational. The object's kinetic energy can be known only if the speed and mass of that body are known. Does kinetic energy increase after a collision? Kinetic energy does not increase after a collision process. We know that, in general, kinetic energy in a collision will be constant. The total kinetic energy of the bodies in contact after collision does not increase as it violates the universal laws of conservation of energy. What is the definition of the oblique collision? Oblique collision is one of the essential types of collision. Considering there are two objects, a line is drawn such that the center of masses of both the objects is not in parallel to the direction of the object velocities. This type of collision is known to be an oblique collision. In an oblique collision, the objects will not be parallel. For an oblique collision to occur, objects should have dimensions. Can the conservation of kinetic energy be negative? From the formula to find the Ke, we can say that the conservation cannot be negative. The mass term mentioned in the formula cannot be harmful, and even the V2 cannot be negative. Hence the kinetic energy cannot be a negative quantity. If there is a motion, then Ke is positive, and if there is no motion, then 0 Ke, and the conservation cannot be negative. Does kinetic energy depend on the direction of motion of the object? The quantity of kinetic energy cannot depend on the direction of the route along which the body is under motion. We know that kinetic energy is a scalar, as the characteristic of scalar quantity signifies that it does not focus on the direction of a particle. How does the change in kinetic energy affect the amount of work a body can perform? The work on a particle or body can be done when it moves, or when a particular force is applied. From the work energy theorem, we can say that work performed on a body will equal the specific change in kinetic energy of the same body in motion. If we can calculate the change in Ke, it is possible to determine the amount of work done by the object or a body. Name some factors that affect the rate of kinetic energy. The two critical fundamental factors that affect the kinetic energy of the body in motion are given below. The first factor that affects kinetic energy is the body's mass. If the mass is more, Ke is more and vice versa. The second factor that changes the particle's kinetic energy rate is taken from its formula, that is mass and its velocity. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.